Welcome back, students. So now we're going to talk about, in our last lesson we talked about one-step equations and how to solve our one-step equations, and now we're going to talk about two-step equations. So we're just basically going to just jump right on in. With a two-step equation, our first is to zero out the constant. That's our first step. And so in this case, we have plus 12, and so the opposite of plus 12 is to minus 12. So we're going to subtract 12 from both sides. So that was our subtraction property of equality. So that's what I'm using right here. I'm just going to bring down the x. Sorry, I was interrupted by announcements. So from here, we're just going to rewrite x divided by 4. Positive 12 minus 12 becomes 0, which is what we want to have happen. And then 32 minus 12 is 20. Now, from here, we want to, our second step is going to be that we want a coefficient of 1. Coefficient of 1. And in order to do that, that's multiplying or dividing. So since this right now is division, the opposite would be to multiply. So I'm going to multiply, and what I do to one side, I have to do equally to the other side. And so that's my multiplication property of equality, MPOE. And so 4 times x divided by 4 leaves us with just x, because 4 divided by 4 is 1, and equals, and then 20 times 4 is 80. And so that should be our answer. Now, if you're not sure, you don't need to ask me right away. We're going to use substitution property, and we're going to plug this in to double check. And you can do this into your calculator. That's fine. You don't have to always write it out. But I'm going to write it out. So we're substituting x with, or 80 for x. So where my x was, I'm going to put 80 divided by 4 plus 12. And so 80 divided by 4 is 20. And 20 plus 12 equals 32. And so since this equals this, and so that makes it a true statement. So that means that x does equal 80. And so that's how we can check our work. We've learned the substitution property. Having learned the substitution property, as I drop my microphone. Sorry about that. Having learned the substitution property, we can use it to double check our work. This is also another way that if you're being asked to solve equations and you're not exactly sure, you can use the substitution property if you're given multiple choice in order to, double check them. It'll take longer, but that's one way you can use multiple choice to your advantage. All right, moving on to example 2. There we go. So again, I want to start by zeroing out my constant. My constant in this case is the 3. I'm always worried about the constants next to my variables or with my variables. So in this case, our variable x is on the left-hand side or on the right-hand side instead of the left. But that doesn't matter. I'm going to look at my constant, which is 3. This is a positive 3. What is the opposite of a positive 3? To minus 3, because I want to get to 0. And so I'm going to subtract 3 from both sides. So that's subtraction property of equality. So this becomes 0 over here. 35 minus 3 is 32. So we'll have 32 equals 5x. Here we're multiplying. So I want to make it equal 1. And so the opposite of multiplying is to divide. And to make it equal 1, I've got to divide by what my coefficient is, which is 5. So I'm going to divide both sides by 5. Now, you may be sitting there going, oh, but Mrs. Cartwright, that's not a whole number because it doesn't end in 0 or 5. Well done, you are correct. At this point, I am happy with 32 fifths. There's yours. 32, oh, of course it did. 32 fifths equals x. So leaving it as an improper fraction, that's completely fine. If Math Excel is being picky And it says to make it a mixed number, so look at what Math Excel wants it to be. Then you would make it into a mixed number. 5 goes into 32 6 times, so we have a whole number of 6. And then 32 minus 30, because that's what 5 times 6 is 2, so we'd have 6 and 2/5 would be our mixed number. Now, to be honest, this is my preferred answer. I am perfectly fine with you leaving it in a reduced form, but nothing goes into both 32 and 5, so that is reduced. But I would prefer the improper fraction, and your high school teachers are going to prefer the improper fraction over the mixed number. And then from here, we're going to just double check and make sure that this works. So 3 plus 5 times 32/5. And so when I do that, I'm going to get 3 plus 160, because that's what 32 times 5 is, fifths. And 160 divided by 5 is 32. And 32 plus 3 is 35. And so I have 35 here and I have 35 there. So that means that we did it correctly. And I forgot to write that when we divided both sides by 5, we used the division property of equality. I think I mentioned it, but I didn't write it. All right. On to our next one, probably the last one for this video, and then we'll start a new set of videos with just the last few examples in it. But we're going to work with a word problem here. We have a 22.8 pound cat needs to lose weight. If the owner follows the vet's weight loss plan, the cat will lose 0.4 pounds per month. After how many months will the cat weigh 14 pounds? So we have our start weight, right? Start weight, which is 22.8. We know that we want to lose, so that means negative. And when we see this per, that tells us that we're multiplying. So this is our coefficient, right? But we know that we are wanting to lose per month 0.4. And since it's lose, technically it's going to be a negative 0.4. And then what we don't know, or we have our goal weight, right? Goal weight, because that one we do know, is 14. And then what we don't know, our unknown, right, is months, the amount of time. We're going to call that T for time. You could call it anything, really. I would try to avoid O's because those look like zeros, right? There's certain letters that I try to avoid, but T with the little curve, it's used quite often. All right, so this is how we're going to set this up. We know that it is 22.8 pounds. We want to lose, so we're going to subtract 0.4 pounds per month. So month is T, right? So I'm going to put 0.4 T. Now the 22.8 is not going to have anything next to it because that's what he's starting at. That is a constant. He is that weight. And we want to see when he gets down to 14 pounds. So that's our equation that we're working with. Now, you can work it with decimals. Mrs. Cartwright doesn't like to work with decimals. So I'm going to use our both the distributive property, but I'm going to use that multiplication property of equality. And I'm going to multiply by a power of 10 that moves my decimal. Because remember, we can move our decimals by multiplying by powers of 10. So since I only have one decimal in each of these, I'm just going to multiply by 10. And I've got to multiply both sides by 10. So I'm going to do 10 times 22.8, which will give me 228, minus, and then, because I'm going to distribute this, and then I'm going to take 10 times 0.4, which will make this 4t, equals, and then 14 times 10 is 140. Now, basically we have the same numbers. I just made it to where I don't have to work with decimals, which sometimes if you're working without a calculator, that makes it easier. From here, we're going to do our subtraction property of equality, and we're going to subtract 228 from both sides. And so that will give me a negative 4t equals a negative, because the 228 is bigger, negative 88. And then I'm going to use my division property of equality, and I'm going to divide both sides by, I want to make it 1, so it's going to be a negative 4 that I divide both sides by. And so my time is going to be t equals 22 months. And we could plug that in. Oops, I'm like going everywhere with that box. I can plug that in and double check, but what we're going to find out is that that indeed works. And we would have gotten the same thing if I kept it as decimals also. Like I said, to me, it's just easier to work with whole numbers than decimals. We will do the other examples on the next video. So I'll see you there.